Welcome to lecture 11. We are studying electronic devices and circuits, and today we'll solve a problem related to the design of a BJT biasing circuit. Before this lecture, we have studied BJT biasing, analysis of BJT biasing. The primary difference between analysis and design problems is that for an analysis problem, the value of resistors, for example, RB, RC, RE, are given in addition to VCC, and we have to find out different voltages and currents at different points in the circuit. For example, IC, IB, VE, VCE, IC, etc. For a design problem, it is vice versa. Voltages and currents at different points in the circuit are given. For example, IC 2 milliampere is given. VE voltage drop across emitter resistor, or the voltage of emitter terminal with respect to ground is given. And we have to find out the values of resistor. For example, in this case, we have to find out RB, RC, RE, etc. These type of problems are called design problems, where we have to find out the values of resistors given different voltages and currents. Next, we will solve this problem to find out the values of RB, RC, and RE. It can be seen that this 2.4 volts voltage is across this resistor RE, or its voltage of the emitter terminal with respect to ground. We can write VE is 2.4 volts. We know that the base emitter voltage drop is 0.7 volt because base emitter junction is forward biased. So this voltage is VBE and is equal to 0.7 volts. To find out the voltage of base terminal with respect to ground, we need to add this voltage VE plus VBE. VE is the voltage of emitter terminal with respect to ground. So VB is VBE plus VE, 0.7 volt plus 2.4 volts. 7 plus 4, 11. This is 3.1 volts. Once we know VB, the voltage of base terminal with respect to ground, we can find out IB. IB is the current. IB is the current flowing through this resistor. IB is the current flowing through this resistor RB. To find out the value of RB, we must understand that according to Ohm's law, the voltage drop across RB is VCC minus VB. The voltage difference between the voltage at the difference of voltages between its upper and lower ends is VCC minus VB divided by RB should generate IB. So IB, according to Ohm's law, is the voltage drop across resistor RB divided by its value. So the voltage drop is VCC minus VB divided by RB. Right, in this equation, we don't know RB, we know VCC, it's 12 volts, we know VB, we have just calculated, this is 3.1 volts. We don't know IB, but we can straight away calculate IB because we know IC 2 milliampere. If you divide it by beta, it becomes IB. So IB can be written as IC over beta because IC is beta times IB. So now we know IC it's 2 milliampere, beta it's 80, we know VCC 12 volts, we know VB it's 3.1 volts. So in this equation there is only one unknown. So let's put all these values. 2 milliampere divided by 80, 12 minus 3.1 volts just calculated divided by RT. So we have only one equation and one variable. If we solve, we yield RB is equal to 35.6 kilo ohm. So RB is 35.6 kilo ohms. Once we have calculated RB, we can calculate RC. RC, we know that the current through RC is, according to Ohm's law, the voltage drop across this resistor RC divided by its value. So IC current, according to Ohm's law, IC current is the voltage drop across this resistor RC, which is VCC minus VCC minus VC. This VC is 7.6 volts over RC. So we know IC, this is 2 milli, 12 minus 7.6 divided by RC. So in this equation we have only one unknown. If you solve it, the value of RC turns out to be 2.2 kilo ohms. Lastly, we have to find the value of RE. We know the voltage drop across it 2.4 volts. If we somehow know the current flowing through it, we can apply Ohm's law and find RE. Let's see what is the current flowing through RE. The emitter resistor. We already know that it is IE, and we also know that IE is IB plus IC. So IB is IC over beta plus IC. IC is 2 milli over beta is 80 plus 2 milli. So IE becomes 81 over 40 milliamperes. Over 40 milliamperes. So once we know IE, we can find out the value of RE because we know the voltage drop across it. So by applying Ohm's law, RE is the voltage drop across emitter resistor divided by the current flowing through it. So VA is 2.4 volts divided by IE, which is 81 over 40 milliamperes. Solving this, we get RE is equal to 1.18 kilo ohms. So we have solved a design problem where we have calculated the values of RB, RC and RE, given some currents and voltages. In the next lecture, we'll start chapter number 5 and we'll study AC amplifiers, BJT based and AC amplifiers. Thank you.